All right, students, so this video is going to show you how to perform regression in SPSS. Now, if you'll remember from the lecture, there's quite a few steps that you need to go through in order to perform regression if you're doing it by hand. The benefit of SPSS is it does in a few seconds what, if you were to do this by hand, probably take you almost like months. Probably a little bit of an exaggeration, but it would take you a long time to do all that. So let's go ahead and take a look at what we'd start. So typically, if you remember from the lecture, the first step in regression analysis is to create a scatter diagram. So let's just say I want to examine, and of course, another thing about regression is you need two interval ratio level variables. Your independent variable needs to be interval ratio, and your dependent variable needs to be interval ratio as well. So let's just say I want to look at the relationship between your education, and by this, I mean the years of education, because we need interval ratio level data. There's a couple of variables that measure education. There's degree, which is ordinal, and then education, which is interval ratio. So we're going to be looking at interval ratio because we know that, or education because we know it's interval ratio. I want to see how your education level influences how many TV hours, how many hours you spend per day watching television. And that variable, I think, is TV hours, which again is scale, which is interval ratio. So what I do, the first thing that I would do to start this analysis is I would create a scatter diagram. How do I create a scatter diagram? I'm going to come up here to this graph section, and then I'm going to click on legacy dialogues. Okay. Now after I click on this legacy dialogues, I'm going to come over here and I'm going to find this scatter dot here, and I'm going to click on this. Click that. Now I'm going to just choose the simple scatter because that's going to be the easiest one. Define. Okay. Now I have my variable labels. I'm going to display variable names. And if you remember from the lecture, we have the independent variables on the x-axis and the dependent variables on the y-axis. So if I'm looking at the relationship between education level and how many hours per day you spend watching television, your education in years is going to be the independent variable. So I'm going to find education. I'm going to click it into the x-axis, which we know is the independent variable. I'm going to find TV hours. I'm going to put it into the y-axis, which I know is, again, the dependent variable. And then I'm just going to press OK. Okay, now I have a graph. And looking at this scatter diagram, it kind of looks like it's all over the place. And I kind of find I'm having a hard time actually interpreting this scatter diagram. So what I'm going to do is I'm going to have SPSS create a line. So what I need to do here is I need to double click this. And then what's going to pop up is this new box. Okay, I still don't have my line. So what I need to do is I need to come over here. I need to click on elements. I click on elements. I'm going to scroll down to this fit line at total. So I click here. That opens up another box, okay? And then after I open up this other box, I'm going to click fit method is going to be for linear. So I'm going to click linear. I'm going to press apply. Then I'm going to press close. And now I see this line, the regression line, okay? I'm going to press file, and then I'm going to close. And now I see this line here. So the constant, or the y-intercept, is 5.3, and then the slope is 0.17. So for any number that we have for the independent variables, so let's just say that we know we had 10 years of schooling, I could predict the value of the y, or the value of the dependent variable. I can predict how many hours per day an individual spends watching television. Or, for somebody with 20 years of schooling, I could predict how many hours per day they spend watching television. So that's how we go about creating a scatter diagram, as just kind of like the first step in regression analysis. Okay. Now, the next step that we might want to do is we might want to see the correlation between these two variables. And then the way we're going to go about producing correlation coefficients is, well, actually this 0.177 actually tells us how well they're correlated, but we're just going to continue just to show you this process. So what we're going to do here is we're going to press analyze, okay? And then we're going to press find the correlate, and then we're going to click on bivariate, okay? Now what I'm going to do is I'm going to, again, display the variable names. And all I need to do at this point is to click those two variables in. So I'm looking for educ as my independent variable and then TV hours as my dependent variable. I press OK here. And then, like I said, what it does is it provides me a correlation coefficient or a correlation for these two variables. So here we have, again, for high school, year of school completed, and then hours per day watching TV, we see that the correlation is negative 0.177, which tells us it's a pretty weak correlation. And then obviously, because there's only two variables here, it crosses it. So here we have high school year completed, and then hours per day watching TV, negative 0.177 as well. If you're wondering why it's in two places, because you could have thrown like 3 or 4 of those variables in, and then obviously you would have like 1, 2, 3, and it would show how they're correlated with each one of them. So that's why you see it in two places. But we've only had two variables, so you might be like, well, why do you see it twice? It's because you could throw in more than 2, and then it would show like a cross matrix. So another thing that it provides us here is it tells us the significance level. Now, what do we mean by that? It tells us how, if these two variables are correlated, is this relationship statistically significant? And we can see that this relationship is statistically significant at the 0.01 alpha level because of these two asterisks. Okay, so you see an asterisk here, and you see, try to zoom in. I guess it's not letting me zoom in. So if you see this asterisk here, and you see this asterisk here, you see it as well here. So typically when you're reading an output, and then you're looking at regression, and you see an asterisk by it, if you're looking at an output and you're doing any type of like statistical hypothesis testing procedure, you see an asterisk by the number. What that means is that it's statistically significant. Now, if you see one asterisk, it means that it's statistically significant at the 0.05 alpha level. If you see 2 asterisks, it means it's statistically significant at the 0.01 alpha level. And if you see 3, obviously it means it's statistically significant at the 0.001 alpha level. Okay, so we know that with these 2 asterisks, it's statistically significant at the 0.01 alpha level. Also, it says it down here, 2 asterisks, correlation is significant at the 0.01 level for a two-tailed test. Now, having said that, we've found the correlation. We also have the correlation up here. We created a scatter diagram. Let's just say we want to continue with our analysis and we actually want to do the regression procedure. So what we're going to do at this point is we're going to come over to Analyze. We're going to come over here to Regression, and we're going to click on Linear. Okay. Now, again, I'm going to display variable names. And I'm still looking at education and TV hours. So I know that TV hours is my dependent variable. So I'm going to find TV hours. I'm going to click it into the dependent box. And then I'm going to find education. I'm going to click it into the independent box. Now, even though you see quite a bit of stuff here for this relatively elementary introduction to regression, we're just going to show you this, okay? So now that I have TV hours as a dependent variable, education as the independent variable, I'm going to press OK. Now it's going to provide me with quite a bit of information, okay? Now, it's going to give me the R, which is the correlation coefficient. So if you remember, the Pearson's R, the correlation coefficient is 0.177. You're going to see it here. So this is where the R is. And like I said, that obviously is consistent with what we saw from this output. And it's also consistent with what we saw from the scatter diagram. So we know that the correlation coefficient or the slope is 0.1, what's it again? 0.177. Yeah, correlation coefficient is 0.177. Now the R squared is 0.031. Now the way you get the R squared, well, again, you learned the equation in the lecture. You could just take the R and square it up, right? And down here further, you're going to see 5.304. So this is a constant. What is the constant? The constant is the y-intercept. So it's the value of the y when the x is equal to 0. So when the independent variable is 0, that's the value of the y. And right below that, you have the slope, which is the rise over the run. So which is for every 1 unit change in the independent variable, you have this much decrease in the dependent variable. So we see that it is a decrease of negative 0.172, sorry, negative 0.172. So that's the slope here. This is the y-intercept. Here we have the f. Now, the f is calculated in regression to determine whether or not you're going to reject or fail to reject the null hypothesis. And you're going to use the distribution of f, which you've learned about the distribution of the f in the ANOVA chapter. And then we can look over here to the significance. And we can see that the significance level is 0.000, which means it's below the 0.05, 0.01, and below the 0.001 alpha level, which means that this relationship is statistically significant at all 3 levels. Okay, and we can reject the null hypothesis at all 3 levels as well. Yeah, so that's how you go about doing regression. And then obviously if you know the slope and you know the y-intercept, you can predict the value of the dependent variable for any and all values of the independent variable. Last thing I'm going to show you how to do is I'm just going to quickly show you how to do multiple regression, even though I don't think that you have to do this in this class. What you're going to do is you're going to come back up here and you're going to click on Analyze, Regression, and I click on Linear. Let's just say that I also think that maybe age influences, how many hours a day you spend watching television. So what I would do is I would click age into this independent variable box, press OK. Now you're starting to see that once we control for age, things change, right? So the R changes to 0.269, which means that there's a weak relationship between these 2 variables. That is education and an age of respondent and TV hours per day. The R squared also changed to 0.073. The constant changed to 3.472. And then here, the slope for highest year of school completed is negative 0.162. So that means by holding age constant, we can see that for each additional year of schooling, time you spend in school, you're having a negative 0.162 or 0.162 decrease in the amount of time you spend watching television each day. Okay, and obviously this is defined in within an hours, right? So that is how you go about conducting regression in SPSS.